Hello, everyone, and welcome back to SciVid. Today, we have an electrifying topic that's at the core of our modern world: nuclear energy. It's a force that's been harnessed for both good and controversial reasons. So, buckle up as we unravel the power within, understanding nuclear energy and its impact on society. In the grand tapestry of human exploration, nuclear energy emerges as a potent force drawn from the very core of matter. It's a captivating odyssey through the corridors of time and the realms of science, a narrative stretching across centuries, imprinting its influence on every facet of our existence. Beyond being a mere scientific curiosity, nuclear energy seamlessly integrates itself into our contemporary being. As we plunge into the labyrinthine world of atomic nuclei and the forces orchestrating their dance, we'll unearth the bedrock principles governing nuclear reactions. The pioneers of nuclear science, from Marie Curie to Enrico Fermi, shall grace our exploration, illuminating the path to understanding this formidable force. We'll scrutinize how humanity has harnessed nuclear energy to illuminate our cities, furnishing a substantial chunk of our power needs. Alongside this journey, we'll tackle the environmental concerns and ponder the global implications for energy security associated with nuclear power. But nuclear energy isn't confined to the realm of electricity, it's a savior of lives. Our expedition will navigate the enthralling domain of medical applications, from diagnostics to combating cancer. However, the shadowy link between nuclear energy and weapons cannot be ignored. The discourse surrounding nuclear energy remains an ongoing narrative. Some herald it as a pristine, efficient energy font, while others shudder at its latent perils. We'll navigate this intricate conversation, weighing the pros and cons entwined in the fabric of nuclear energy. Our lens will extend to how different nations approach this force and the role it plays in their energy landscapes. Safety and regulation reign supreme in the realm of nuclear energy. We'll scrutinize the stringent safety measures in place and their evolution over time. The web of public perceptions and misconceptions surrounding nuclear energy will also come under our scrutiny, dissecting their impact on societal acceptance. As we stand at the crossroads, we'll reflect on the expedition, distilling the key points and contemplating the intricate interplay of science, society, and nuclear energy. Strap in for an enlightening voyage through the expanse of nuclear energy, from the tiniest atomic nucleus to the colossal power plants, unraveling the enigmas of this extraordinary force and exploring its profound impacts on our world. The saga of nuclear energy commences with the elemental building blocks of matter: atoms. At the nucleus of every atom, a minuscule, densely packed core cradles protons and neutrons, containing a colossal reservoir of dormant energy, awaiting release. Atoms, the fundamental constituents of matter, envelop us ubiquitously, forming the fabric of everything we perceive, touch, and breathe. Yet, within these seemingly commonplace particles lies extraordinary potential. The nucleus of an atom is the stage for the grand performance. Protons and neutrons, bound tightly by the formidable nuclear force, dance in a cosmic ballet. In the early 20th century, scientific trailblazers embarked on unraveling the atom's secrets. Icons like Ernest Rutherford and Niels Bohr spearheaded groundbreaking discoveries, revolutionizing our comprehension of atomic structure. Rutherford's iconic gold foil experiment laid bare the atom's predominantly empty nature, unveiling a minuscule, dense nucleus at its core. Albert Einstein's iconic equation, E=mc superscript 2, laid bare the immense energy concealed within matter, depicting the conversion of a minute mass into an astronomical energy yield. This equation stood as the bedrock of nuclear physics, paving the way for the evolution of nuclear energy. Our expedition delves into the elemental particles and their intricate interplays, unveiling the genesis of the energy ensnared within atomic nuclei. The spotlight also falls on isotopes, pivotal players in the cosmic ballet of nuclear reactions, setting the stage for our odyssey into the annals of nuclear science's history, where the race to harness this energy unfurls. So, Secure your seatbelts as we embark on a sojourn to demystify the secrets of the atom, uncovering how a force so minute wields monumental power, reshaping the trajectory of human history. We shall trace humanity's remarkable quest to unleash and harness this power, navigating the triumphs, trials, and ethical quandaries awaiting in the realm of nuclear energy. Journeying through time, we plunge into the captivating history of nuclear science. A history punctuated by groundbreaking revelations and an insatiable thirst for knowledge. Our sojourn commences in the early 20th century, an era witnessing giants like Ernest Rutherford, Niels Bohr, and James Chadwick making significant strides in unraveling the atom's structural mysteries. Rutherford's nuclear model, Bohr's atomic blueprint, and Chadwick's unveiling of the neutron laid the cornerstone for nuclear science. These visionaries unveiled the secrets of the atom, setting the stage for one of the most transformative scientific domains in history. A pivotal juncture in nuclear science's annals was the unearthing of radioactivity, a natural spectacle manifesting in certain elements. This phenomenon led to the identification of radioactive isotopes, realizing that the atom's nucleus could undergo spontaneous metamorphoses, emitting radiation in the process. Pioneers like Marie Curie and Pierre Curie left an indelible mark in this arena, earning Nobel Prizes for their groundbreaking contributions. The revelation of radioactivity cracked open the door to comprehending nuclear decay and the liberation of energy in the form of radiation. This concept laid the groundwork for the evolution of nuclear energy and its myriad potential applications. Embarking on the historical journey, we venture into the tumultuous era of World War II, a period marked by a dark twist in nuclear science. The clandestine Manhattan Project, a U.S. research and development endeavor, culminated in crafting the world's inaugural atomic bomb. This pivotal moment not only shifted the trajectory of nuclear science but also altered the course of global events by introducing the devastating power of nuclear weapons. Post-World War II, the focus of nuclear science pivoted towards the constructive applications of atomic energy. Nations began harnessing the atom's power for electricity and diverse applications, ushering in a new era of energy production. The narrative unfolds, exploring early nuclear reactor experiments and the genesis of the nuclear energy industry. This epoch witnessed the emergence of nuclear arms control agreements, including the Non-Proliferation Treaty (NPT). As we delve deeper, an appreciation for the challenges and opportunities shaping the field crystallizes. The history of nuclear science unfolds as a tapestry rich with discoveries, moral quandaries, and a vision for a future where atomic power benefits society rather than causing destruction. Our journey through nuclear science's annals unfolds, revealing remarkable discoveries and transformative events molding our understanding of the atom. Now, we plunge into the genesis of nuclear energy, the moment humanity unlocked the colossal power concealed within atomic nuclei. The dawn of nuclear energy dawned with the revelation that certain elements, when subjected to nuclear reactions, could unleash an immense energy reservoir. The key to this revelation was understanding nuclear fission, where an atom's nucleus splits, liberating a substantial energy amount. Scientists Otto Hahn, Fritz Strassmann, Lisa Meitner, and Otto Frisch laid the groundwork for this groundbreaking concept. Yet, it was physicist Enrico Fermi and his Chicago team who, in 1942, conducted the first controlled nuclear chain reaction, marking the true birth of nuclear energy. This milestone opened doors to harnessing nuclear fission's colossal power for practical applications. The pursuit of controlled nuclear fission intensified during World War II with the Manhattan Project striving for nuclear weapons development. The successful creation of the atomic bomb underscored nuclear technology's dual nature, harboring potential for both destruction and progress. Post-war, attention shifted to the peaceful use of nuclear energy. Scientists envisioned a world where nuclear reactors could provide limitless electricity. Experimental reactors like Chicago Pile 1 and X-10 graphite reactor laid the foundation for the burgeoning nuclear energy industry. Nuclear power plants emerged, with experimental breeder reactor 1 EBR-1 in Idaho becoming the world's first electricity-producing nuclear reactor in 1951. This marked a new era in electricity generation, promising vast energy resources with minimal greenhouse gas emissions. As we delve deeper into nuclear energy's birth, we unravel its promises and challenges, setting the stage for exploring applications, implications, and its profound societal impact. We zoom in on the core of this technology: nuclear reactors. Nuclear reactors, intricate machines designed to control and harness nuclear fission energy, stand as the heart of the nuclear power industry. They are the source of electricity for millions worldwide. Understanding their workings is pivotal to appreciating nuclear energy's intricacies. At the nucleus of every reactor lies fuel, typically enriched uranium or plutonium, prepared meticulously to initiate and sustain nuclear fission. The chain reaction, initiated by a neutron colliding with a nucleus, releases immense energy in the form of heat. Our exploration extends to the various reactor components: fuel rods, control rods, and coolant systems, all crucial in maintaining the reaction. Control rods adjust fission rates for stability, while coolants transfer heat to a steam generator. The generated steam drives turbines, producing electricity highly efficiently and with minimal greenhouse gas emissions. Diverse reactor types like pressurized water reactors (PWAs), boiling water reactors (BWRs), and fast breeder reactors (FBRs) each carry unique designs and characteristics. Safety takes center stage in nuclear reactors, with multiple systems in place to prevent accidents and mitigate consequences. Control systems, emergency cooling mechanisms, and containment structures play pivotal roles. We touch on the concept of nuclear reactor meltdowns, examining incidents like the Chernobyl disaster and the Fukushima Daiichi incident. This comprehensive exploration equips us with a deep understanding of nuclear reactors, the key to unlocking nuclear energy's potential. By the journey's end, you'll possess a solid grasp of these remarkable machines' operations and the measures ensuring their safe, reliable performance. Our expedition into the inner workings of nuclear reactors, the nucleus of nuclear energy production, concludes. Now, we delve into how nuclear energy is harnessed to generate electricity, powering homes, industries, and societies worldwide. The landscape of electricity provision has witnessed a transformative shift, with nuclear energy emerging as a pivotal contributor to global power demands. Its indispensability lies in the remarkable combination of reliability and the capacity to generate substantial electricity while keeping greenhouse gas emissions to a minimum. This places it squarely in the core of many nations' energy portfolios. The intricate dance of transforming nuclear energy into electricity unfolds within the nuclear reactor. As previously explored, the controlled fission of uranium or plutonium fuel rods generates an intense heat. This heat, in turn, becomes the driving force behind the creation of steam, powering turbines intricately connected to generators. The graceful spin of turbines results in the generation of electricity, dispatched promptly to the grid for widespread distribution. Nuclear energy's reliability in electricity generation stands out as a key advantage. Unlike several renewable sources, such as wind or solar, nuclear reactors boast uninterrupted operation, ensuring a steadfast power supply. This stability proves critical in meeting the unyielding energy demands of our modern society. Our journey will delve into diverse nuclear power plant types employed for electricity generation, including pressurized water reactors (PWRs), boiling water reactors (BWRs), and advanced gas-cooled reactors (AGRs). Each design presents unique features, advantages, and, of course, challenges. Safety measures form the bedrock of reliable nuclear power plant operations. Rigorous training for plant operators, coupled with regular maintenance, inspections, and comprehensive emergency response plans, ensures the seamless functioning of these crucial energy hubs. Exploration extends to the environmental facets of nuclear energy in electricity generation. The absence of carbon dioxide (CO2) emissions distinguishes nuclear power plants from conventional fossil fuels, major contributors to climate change. Yet, the nuclear industry grapples with challenges related to waste disposal and plant decommissioning, Topics we will dissect comprehensively. A holistic understanding of how nuclear energy metamorphoses into electricity and its role in addressing contemporary energy needs will be gained. We'll scrutinize the advantages and challenges, situating this energy source within the broader panorama of electricity generation. Having traversed the realm of nuclear energy in electricity generation and its pivotal role in meeting global energy demands, our focus shifts to the intricate relationship between nuclear energy and the environment. The clean label often ascribed to nuclear energy stems from its minimal greenhouse gas emissions during electricity generation, setting it apart from carbon-intensive fuels like coal and natural gas. However, the environmental impact transcends the carbon footprint. Foremost among environmental concerns is the management of nuclear waste, a byproduct of the fission process within nuclear reactors. These highly radioactive remnants demand secure containment and management spanning thousands of years. Our exploration will venture into the challenges of nuclear waste disposal, assessing methods such as deep geological repositories and reprocessing techniques. The use of water for cooling in numerous nuclear power plants introduces another environmental consideration. The discharge of heated water into rivers and oceans bears local ecological implications, affecting aquatic life and ecosystems. Our examination will scrutinize these consequences and the endeavors to minimize harm, including closed-cycle cooling systems. Furthermore, we will unravel the broader ecological and environmental impacts of uranium mining, the primary fuel source for many nuclear reactors. The extraction of uranium ripples through local communities and ecosystems, prompting discussions on mitigating these impacts and exploring alternative fuel sources like thorium. In the world of nuclear incidents, though infrequent, the environmental repercussions can be calamitous. We'll delve into the environmental impacts of notable nuclear accidents like Chernobyl, Fukushima, and 3 Mile Island. This exploration will encompass the enduring effects on wildlife and ecosystems. Furthermore, we'll scrutinize the measures taken to alleviate environmental harm post such incidents. On a positive note, nuclear energy emerges as a pivotal player in tackling the global climate change challenge. As nations strive to curtail carbon emissions and shift towards cleaner energy sources, the role of nuclear power in a sustainable energy future becomes a subject of ongoing debate. Our focus shifts from the environmental considerations of nuclear energy to another critical facet: its influence on global energy security. Energy security encompasses the availability, affordability, and reliability of energy sources, and nuclear energy significantly addresses these concerns on both national and global scales. An advantage of nuclear energy in security terms lies in its energy diversity. By diversifying energy sources, nations can diminish reliance on a single fuel, thus fortifying their energy security. Nuclear power plants, relatively immune to fluctuating fossil fuel prices, offer a stable electricity supply. Additionally, nuclear energy aids in reducing energy imports, especially for nations lacking domestic fossil fuel resources. This enhances national energy self-sufficiency, reducing vulnerability to geopolitical tensions or supply disruptions in global energy markets. We'll explore how various countries leverage nuclear energy to bolster their energy security. For some, nuclear power is a cornerstone of their energy mix, providing a dependable electricity source. We'll also scrutinize the strategic importance of uranium mining and nuclear fuel production in ensuring a steady fuel supply for reactors. While nuclear energy enhances energy security in various ways, it also poses security challenges. Safeguarding nuclear materials and facilities is crucial to prevent misuse, including the risks of nuclear terrorism or proliferation of nuclear weapons. We'll delve into the significance of international agreements and organizations, such as the International Atomic Energy Agency (IAEA), in ensuring the peaceful use of nuclear energy and preventing illicit use. Our exploration extends to the intricate connections between nuclear energy and global energy security, considering how nuclear power contributes to the resilience of energy systems, the challenges it presents, and its evolving role in a world where energy security is paramount. Venturing into an entirely different realm, we enter the remarkable world of nuclear energy's applications in medicine. The diverse medical applications of nuclear energy have revolutionized healthcare by providing powerful tools for diagnosis, treatment, and research. At the core of these applications is the controlled use of radiation and radioisotopes. One of the most common medical uses of nuclear energy is in diagnostic imaging. Techniques like X-ray and computed tomography (CT) scans use ionizing radiation to create detailed images of the human body's interior, aiding in the detection and diagnosis of various medical conditions. Nuclear medicine imaging involves the use of radiopharmaceuticals, radioactive compounds that accumulate in specific organs or tissues, enabling the visualization of their function and structure. Positron emission tomography (PET) scans, utilizing the unique properties of positron-emitting radioisotopes, detect and map various diseases like cancer and neurological disorders. PET imaging has become an invaluable tool for early diagnosis and personalized treatment planning. Nuclear energy also plays a crucial role in radiation therapy for cancer treatment. Techniques like external beam radiotherapy and brachytherapy use precisely controlled radiation to target and destroy cancer cells while minimizing damage to healthy tissue. Advances in radiation therapy have significantly improved the effectiveness and outcomes in cancer treatment. Beyond diagnostics and treatment, nuclear energy has enabled life-saving techniques like stereotactic radiosurgery, delivering high doses of radiation with pinpoint accuracy, and radioactive iodine therapy, a common treatment for thyroid conditions. We'll delve into the fascinating world of nuclear medicine, explaining the science behind these applications and their critical role in healthcare. Additionally, we'll explore the challenges and regulations surrounding the use of radioactive materials in medicine and the ongoing research and innovations in this field. As we embark on this journey into the intersection of nuclear energy and medicine, a deeper understanding unfolds of how nuclear technology transforms the practice of healthcare, offering hope and healing to countless patients worldwide. The dual nature of nuclear energy is stark. One side symbolizes progress, innovation, and hope, while the other signifies destruction, fear, and global security concerns. Our exploration into the intricate and often contentious relationship between nuclear energy and nuclear weapons awaits. Nuclear energy and nuclear weapons share a common origin in the understanding of nuclear fission. The principles enabling nuclear reactors to generate power also facilitate the creation of nuclear bombs, forming the core of the nuclear energy debate. Following the war, the world entered the Cold War era, marked by a nuclear arms race between the United States and the Soviet Union. The development of more powerful and sophisticated nuclear weapons became a priority, with each side vying for dominance and deterrence. We'll delve into the science and technology behind nuclear weapons, exploring the design of different bomb types, the principles governing their explosive power, and the devastating consequences of nuclear explosions. The emergence of the Nuclear Non-Proliferation Treaty, abbreviated as NPT, and the initiation of arms control accords aimed to curtail the proliferation of nuclear weapons and foster disarmament. While strides have been taken, global apprehensions persist as various nations possess nuclear arsenals, and others aspire to attain this capability. Our discourse will navigate the moral, ethical, and political quandaries entwined with the dual-use facets of nuclear technology. We shall delve into the hurdles faced by non-proliferation initiatives, scrutinize the ever-evolving global nuclear landscape, and ponder the prospects of a world free from nuclear weaponry. This journey promises a profound understanding of the intricate interplay between nuclear energy, nuclear armaments, and global security, a narrative of immense power, responsibility, and the collaborative endeavors of nations charting a course toward a safer world. Nuclear energy stands as an ongoing subject of contention and debate. Its potential to yield copious electricity with minimal greenhouse gas emissions contrasts with associated risks and challenges, sparking robust public opinions and concerns. The discourse around nuclear energy is multifaceted, encompassing diverse perspectives. Advocates argue that it is indispensable for transitioning to a low-carbon future, highlighting its reliability, capacity, and minimal greenhouse gas emissions integral in combating climate change. Additionally, nuclear energy furnishes a dependable electricity source, mitigating the intermittency issues linked with renewable sources like wind and solar. Conversely, opponents raise valid concerns. Safety, with the potential for accidents and their environmental repercussions, takes center stage. The management of nuclear waste, nuclear proliferation, and the exorbitant costs tied to constructing and maintaining nuclear power plants all fuel debates. Ethical and social considerations amplify the discourse. The historical nexus between nuclear weapons and the ominous power of atomic bombs instills deep-seated fears and public distrust. Communities in proximity to nuclear facilities express safety concerns and contemplate the enduring consequences of nuclear power generation. Our exploration will scrutinize arguments from both ends of the nuclear energy spectrum, presenting a nuanced perspective that weighs the advantages and challenges posed by this energy source. We'll dissect the myriad factors shaping public opinion and policy decisions, unveiling an evolving discourse within the climate change and energy transition framework. This journey guarantees a nuanced comprehension of the intricate dynamics surrounding nuclear energy and its role in the broader energy landscape. The debate acts as a poignant reminder that energy choices aren't solely dictated by scientific and technical factors but are equally influenced by societal values, ethics, and the intricate interplay of politics and public perception. Diving into the exploration of nuclear energy, a phenomenon spanning the globe with diverse applications and distinctive approaches in different nations, we embark on a global odyssey. Our journey seeks to unravel how nations perceive and utilize nuclear energy on a grand scale. The role of nuclear energy exhibits significant disparities among countries. Some nations embrace it as a cornerstone of their energy portfolio, while others opt for a phased withdrawal. The motivations behind these decisions are multifaceted, reflecting a nation's distinct energy requirements, resources, and socio-political considerations. Consider the United States, boasting a diverse array of nuclear power plants that contribute substantially to electricity generation. In contrast, France heavily relies on nuclear energy, with over 70% of its electricity sourced from nuclear reactors. Both countries have made substantial investments in nuclear technology and infrastructure. On a divergent path, Germany initiated a nuclear phase-out post the Fukushima disaster, adopting an energy Wende or energy transition, aiming to replace nuclear energy with renewables, showcasing a noteworthy example of a nuclear power reduction policy. China and India are aggressively expanding their nuclear capabilities to meet escalating energy demands, viewing nuclear energy as a means to curb greenhouse gas emissions and ensure energy security. Further exploration extends to countries like Russia, South Korea, and the United Kingdom, each with its unique history, policies, and visions for the future. A probing investigation into international cooperation and agreements in nuclear energy, including the IAEA safeguards and the Nuclear Suppliers Group, unfolds. These organizations diligently work towards ensuring the peaceful use of nuclear technology while preventing its misuse. The objective is to gain a holistic, global perspective on the diverse applications of nuclear energy, acknowledging the unique challenges and opportunities it presents across the world's diverse landscapes. Anticipating the future of nuclear energy reveals immense promise and potential, coupled with an array of challenges and uncertainties. The narrative delves into emerging technologies poised to revolutionize nuclear energy, addressing the pivotal role of nuclear power in tackling pressing global issues. 1. Advanced reactors. The nuclear industry stands at the precipice of a new era, embracing advanced reactor designs like small modular reactors (SMRs), high-temperature gas-cooled reactors (HTGRs), and fast neutron reactors. These promise heightened safety, efficiency, and flexibility, a territory ripe for exploration. 2. Fusion energy. Unraveling the mysteries of fusion, the process that fuels the sun, holds the tantalizing promise of virtually limitless, clean energy. The narrative probes the progress and challenges in achieving controlled nuclear fusion on Earth and its potential as a sustainable energy source. 3. Nuclear energy and climate change. Amid escalating concerns about climate change, nuclear energy garners renewed attention as a low-carbon energy source. The exploration navigates how nuclear power can contribute to reducing greenhouse gas emissions, playing a pivotal role in the global fight against climate change. 4. Energy transition. The journey toward a sustainable energy future necessitates a judicious mix of energy sources, encompassing renewables and nuclear power. Delving into how nuclear energy seamlessly integrates into the evolving energy landscape and synergizes with other low-carbon technologies is imperative. 5. Challenges and concerns. The trajectory of nuclear energy's future is not devoid of challenges. The discourse addresses issues ranging from safety and nuclear waste management to public perception, underscoring the imperative for international cooperation to ensure the responsible use of nuclear technology. 6. Exploring the intricate measures and vigilant oversight ensuring the secure operation of nuclear facilities and the responsible utilization of nuclear technology. Nuclear safety, a multifaceted concept, envelops the entire life cycle of nuclear power plants' design, construction, operation, and decommissioning. Its objective is to avert mishaps and shield workers, the public, and the environment from the detrimental impacts of radiation and radioactive substances. 7. 1. Depth in defense. This principle incorporates layers of protection and redundancy, assuring that if one safety barrier falters, others stand ready to prevent the release of radioactive materials. 8. 2. Regulatory watch. Independent bodies like the Nuclear Regulatory Commission (NRC) in the United States play a pivotal role in establishing and enforcing safety benchmarks for nuclear facilities. 9. 3. Cultivating safety, emphasizing the significance of a safety-centric organizational culture within nuclear facilities, spotlighting vigilance, training, and transparency. 10. 4. Readiness for emergencies, methodical planning and training for potential mishaps, guaranteeing swift and effective responses in place to safeguard the public and the environment. 11. 5. Guarding against radiation, shielding the health of workers and the public through defined dose limits and vigilant monitoring of radiation exposure. 12. We'll delve into the insights gleaned from nuclear accidents, including the Chernobyl and Fukushima disasters, and how these incidents have shaped safety practices and regulations. Nuclear facilities, spanning from power plants to research reactors and medical institutions, adhere to stringent safety standards and undergo meticulous inspections. Rigorous protocols ensure equipment maintenance, procedural adherence, and regular testing of safety systems. 13. Additionally, we'll tackle nuclear security, zeroing in on preventing theft or illicit use of nuclear materials for malevolent purposes, such as nuclear weapons development. International accords, like the Convention on the Physical Protection of Nuclear Material, establish norms for securing nuclear materials during transport and storage. 14. By delving into this discussion, you'll develop an understanding of the all-encompassing safety and regulatory framework supporting the responsible application of nuclear technology. Safety and security stand as the bedrock, enabling nuclear energy to fulfill its potential while minimizing inherent risks. Delving into the intricate and multifaceted relationship between nuclear energy and society, we navigate through its social, economic, and ethical dimensions. Unraveling the complexities, we scrutinize how nuclear energy interlaces with communities, impacts economies, and raises ethical questions of paramount importance. Economic impact. The influence of nuclear energy on local and national economies is profound. The construction and operation of nuclear power plants not only generate employment but also stimulate economic development in host communities. At a national level, nuclear energy contributes to enhanced energy security, reduced import costs, and drives technological innovation. Community and public perception. The public's view of nuclear energy spans a wide spectrum, influenced by historical events, safety concerns, and information dissemination. Grasping the dynamics of public opinion and addressing community concerns becomes imperative for the successful execution of nuclear projects. Social and environmental justice. The geographical placement of nuclear facilities often sparks inquiries into social and environmental justice. Communities near these facilities may encounter economic challenges and potential environmental risks. We explore the considerations of social equity associated with nuclear energy. Ethical dilemmas. The ethical challenges tied to nuclear energy are intricate and diverse. Encompassing issues like nuclear waste disposal, the potential for accidents, and the dual-use nature of nuclear technology, we delve into the ethical principles and frameworks used to assess these complexities. Education and engagement. Fostering public understanding and engagement proves pivotal in addressing the social aspects of nuclear energy. Outreach, education, and open dialogue act as bridges, narrowing gaps in comprehension and building trust between the nuclear industry and communities. In gaining insights into the complex relationship between nuclear energy and society, we recognize its social, economic, and ethical dimensions. Implementation goes beyond a technical or scientific endeavor. It is profoundly intertwined with the values, aspirations, and concerns of the communities and societies it serves. The advent of nuclear weapons marked a seismic shift in global security, with their destructive potential capable of catastrophic consequences. Consequently, nations worldwide have actively sought means to prevent the use and proliferation of nuclear weapons. We will explore several key facets of nuclear disarmament. 1. Arms control treaties. The arms control landscape is characterized by various international agreements aiming to reduce the number and role of nuclear weapons. Prominent treaties include the Treaty on the Non-Proliferation of Nuclear Weapons (NPT), the Strategic Arms Reduction Treaty (START), and the Comprehensive Nuclear Test Ban Treaty (CTBT). 2. Deterrence and security. The concept of nuclear deterrence stands as a cornerstone in many nations' security policies. We will delve into the ongoing debate surrounding the role of nuclear weapons in maintaining peace and security. 3. Nuclear weapon-free zones. Regions like Latin America, Africa, and the South Pacific have established nuclear weapon-free zones to promote disarmament and prevent the stationing of nuclear weapons within their boundaries. 4. Global efforts. Various international organizations, including the United Nations and the International Atomic Energy Agency (IAEA), play pivotal roles in promoting disarmament, arms control, and non-proliferation. We will scrutinize the contributions and limitations of these organizations. 5. Challenges and roadblocks. The journey toward nuclear disarmament faces challenges, including the reluctance of nuclear-armed states to relinquish their arsenals, the risks of accidental or unauthorized use, and persistent concerns about proliferation. 6. Emerging technologies. The development of new and more sophisticated nuclear weapons raises apprehensions about the future of disarmament. We will ponder the impact of emerging technologies on disarmament efforts. Providing an in-depth exploration of the global quest for nuclear disarmament, a pursuit ongoing since the dawn of the nuclear age, this analysis highlights the intricate and interconnected web of international agreements, security dynamics, and technological advancements shaping the trajectory of disarmament efforts. Embarking on the culmination of our in-depth exploration into the realm of nuclear energy, we stand at a pivotal juncture. The narrative of nuclear energy unfolds as a tapestry woven with extraordinary triumphs, profound ramifications, and intricate challenges. This technological marvel possesses the potency to redefine our world, offering both blessings and perils. Our expedition through the annals of nuclear energy's history has traversed its conceptual genesis to the practical manifestations we witness today. We've navigated the genesis, intricacies of nuclear reactors, their integral role in power generation, environmental footprints, and their far-reaching impact on diverse sectors, including medicine and national security. Examining the global repercussions of nuclear energy, we've scrutinized the diverse strategies and policies adopted by nations worldwide. Venturing into the ethical, economic, and social facets, we recognize its profound influence on communities, economies, and societies at large. In contemplation of the future of nuclear energy, we ponder its potential in confronting contemporary challenges like climate change, all while acknowledging the obstacles that demand surmounting. In essence, nuclear energy remains a dual-edged instrument, bestowing significant advantages while bearing substantial risks. It stands as a symbol of humanity's prowess in unraveling the enigmas of the atom and harnessing its formidable might for both constructive and destructive purposes. The path ahead remains uncertain, yet one certainty emerges: the judicious and well-informed application of nuclear technology is paramount. As we aspire towards a future marked by sustainability and security, it is our duty to navigate the intricate tapestry of nuclear energy with sagacity, transparency, and a collective commitment to safety, security, and environmental custodianship. It continues its evolution within research laboratories, power plants, and international negotiations. Its legacy will be molded by our collective choices and deeds in the impending years and decades, underscoring the ongoing saga of humanity's interaction with this potent force. In a world powered by atoms, the potential is limitless. From the tiniest particles to the grandest innovations, nuclear energy continues to define our journey toward a sustainable future. Thanks for watching, and don't forget to like, share, and subscribe for more captivating content. Until next time, this is Sivad, signing off.